nodes are humming, systems gonna overload. We got clusters making magic in the line. Funkified computing, baby.
Welcome to Cluster Funk. My name is Ed Fullman.
I am Fabrizio Sgura.
And we're here to talk today about Kubernetes and our new podcast together. Fab, why don't you give a little introduction and I'll do mine.
So personally, I am here to share my 30 years of experience. No. Let's start from scratch. Let's start from when containers were just shipping containers and we were thinking about it as something that was used to deliver us the servers. And today the servers are hosting the containers inside of them. So there's a lot of story here that I would like to share because of my experience. 30 years is probably too much because I was just hitting keys to have processes up and running, working on DOS, whatever, and then Unix. But today it's a little bit different. I would like really, Ed, to share with you what I've been facing in the last 10 years of my career on top of containers, Docker, Kubernetes, and whatever more we will have the time to share for today.
Yeah, as far as myself, my name is Ed Fullman. I've been
You said
working.
that.
Yeah, well, I've been working at this 10 years more than you, so I'm a little bit slower at this point than you are. But yeah, I've been at this from the time when typing in your program meant typing it on a card punch, and back in those days of before laptops and desktops and even CRTs. But I've tried to keep myself upgraded as we've gone through the years. And the last 7 or 8, I've been working in Kubernetes, mainly as a management leader and a product manager and a strategist. But I think we've got some good positions between the two of us and how we look at Kubernetes and the value it creates for us. And that's
I can confirm because in the last 5 years we have been working together. So at least for 5 years you have been working on Kubernetes. Earlier, I don't know.
Evidence. So let's start at the beginning. I asked Fab once upon a time, like, when did you start with Kubernetes? When we first started talking, and I met him. And as I recall, you were pretty much at the beginning of Kubernetes. Obviously, you were working before that, but let's describe a little bit about your view of the background of Kubernetes and how it's come about.
Yeah, so if we go on Wikipedia, we will find that Kubernetes was done by Google 2010, whatever. I started in 2015 with KOps. And at the same time, I was working on Apache Mesos. So generally, for people that are just approaching the problem of what is Kubernetes, what does it mean, and something like that, there was an alternative previously. That was running on top of CoreOS that was developed by Google as an immutable operating system, and it was intended to be something that was a scheduler. So the ability of taking processes, running them, following a specific structure and orchestration, why not? Because the scheduler is orchestrating, and that resulted at that time in a better management of microservices and whatever was the technology around it. So Google started this project in 2010. Effectively, they were thinking to host that privately, just leaving it as a closed source compound. But then they started to see that releasing it would have been very good because the initial project that was called Borg, Omega, and other things that were oriented to manage thousands of applications, you can imagine that inside Google, they had a lot of things. And I think, Ed, in your life, you had challenges on managing a lot of application scaling, also from the past. We were having monoliths. We know about that. And instead of
This was Google's big move to probably step out from all the costs to build such a monumental piece of software as Kubernetes. And
and especially it was hard. I mean, that
get a
was the
community to do
challenge.
it was easily the biggest, project of its time. At least it was in the top 5, if it wasn't number 1, as far as new kind of open source technologies that was looking for a community to take over and take it somewhere. So, I mean, from that perspective, probably Google couldn't have kept it up by themselves much longer anyway. It was probably already pretty big because they were running thousands and thousands of containers with Borg probably. So that just kind of pushed them to do something with a community.
And at that time, there was no community, so they were alone.
Yeah.
I remember that when they released CoreOS to run, both Mesos initially, because it was the initial agreement between Google Mesosphere, then Mesosphere became D2 IQ. There was a marathon runner that was inside the Mesos cluster orchestrating container. It was very similar to Kubernetes, but it was complicated, overcomplicated to run a lot of things on top of that, and it was not community aware. At the beginning, no Kubernetes community was really present, but the initial steps to create the CNCF that today is who is maintaining the Kubernetes enhancement program and whatever is behind the ability to have the worldwide developers for the open source community working around Kubernetes for the scheduling abilities, what we will see more abilities that we have inside Kubernetes. Mesos, the concurrent idea, is today deprecated. That means that in this case, C++ Mesos lost the battle against Golang Kubernetes. And that is also something that is the evolution of the days. Today, we are also seeing a lot of technologies that are behind Rust. So the programming languages are really shaping the future of the organizations. And do not forget that Docker is written in Go. It's something that initially was started as a container runtime written in C and C++, but they gradually migrated to something that was a language at that time that was supported and created at Google. So if we have to find a responsible for today's usage of Kubernetes that we have to do, because it's not just we can do, it is definitely Google. I think that it solves a lot of things. It's a lot of problems, all the containers. And you remember that when we were running Unix systems, we were just running processes, and containers are just processes. But people were doing services and up to operating systems around containers. So that was the big problem in 2015. There was a lot of content inside the container, while the standard is that we know it's better to keep it doing the service, the microservice, a short, small task. And Kubernetes is really powerful in managing a lot of small tasks with configurations and everything.
You couldn't have really built something like the products you and I have worked on. You couldn't have done that without something like Kubernetes. I guess you could have tried, but it would have been very complex with a lot of tightly coupled capabilities and a lot of limits to making it an enterprise software. So I look at it as the organizer, the thing that makes it possible to have a very complex product that's distributed in nature, which is what you and I did. And without that, we could have built some some, monolithic components that just stood by each other, but it wouldn't have been much of a system. And we needed a lot of distribution, which is kind of natural to the way Kubernetes works.
Just to conclude the history of Kubernetes, but just to come back to the current future, comparing to what we did in the past. Before of that, we had manual deployments, a lot of bash scripts, imperative, not declarative. We had then a small step to Puppet, Chef. Orchestration was still a word that was not really present. With Docker, we started having something to orchestrate, the need for orchestration. Docker Compose, creator related as a sort of stack bundle was not really enough. So we needed service discovery, a lot of implications for the network administration, the rules or something that was firewalling, proxying, and whatever was required at that time. So we can conclude the idea of Kubernetes with a sentence. Let's orchestrate this madness, what we had in that past that was so imperative. So based on human abilities, let's produce something that is usable by the team. And this is our focus now, because when we say what is Kubernetes, it is something that will work for the team, with the team, including a lot of abilities to orchestrate, but for having each part of a project, each section, being persons or also concepts, documentation, and similar, homogeneously manageable inside of a single context.
Yeah,
It was a big challenge for us.
From my perspective, just kind of simplifying it, Kubernetes is to me the traffic cop for the entire operation, right?
You always need cops.
Right. Standing in the middle of the street, directing like a giant, one of those circular traffic scenarios where there's lots of people coming at things from many different directions and expecting different outcomes. But a certain amount of calmness and, sorting out the madness so that you can get some expected results. And, I think the other value I was looking for from Kubernetes was the ability to stand up a version of something very much in the same way every time and expect a certain kind of capability every time we stood it up. And from that perspective, make a product out of what we were trying to accomplish. And I think it would have been very difficult to get to that without the orchestration. And, the other side of it was coming back from a problem in a very consistent way every time. To me, that was the other big advantage, right, of orchestrating the things coming back alive after an outage of some sort, or even avoiding an outage by killing something off rather than waiting for it to, essentially become a bigger problem and take out a big part of the system. So to me, those are all the values I was looking for, when we started this activity with Kubernetes so many years ago.
Yeah, I agree. And people could think about Kubernetes now hearing us about just containers or orchestrator, but we have to think that there is a big ecosystem that people built on top of that concept, like the open container standards. So we have container runtimes that are using the ability of running containers and are used by Kubernetes to run containers on top of that. Then there is the orchestrator part, that is this ability we were talking with you, coming from the past, go into the future, the scheduler, traffic cops, whatever is the enthusiastic approach for controlling our flow for applications, and the state. So when we have a lot of enormous thing. We need to maintain a state, a persistent ability to see what is happening, to stop at that state, restart at that state, something that is really known also as event-driven management. And Kubernetes also having these kind of abilities. So when you think that something has to be up and running and it's just a web server, you are not thinking about monitoring it, putting on top of that health checks or liveness readiness probes to ensure that the service is up and running. You just see it as a container on a Docker runtime or a container runtime interface. Kubernetes is doing that much more. That is putting the ability of controlling it, monitoring it, observing it, to use a term that today has to be replaced for monitoring because it's observability, observing the behavior, interacting with that by config maps, having network rules. It's everything. Not going too deep on the technical side, we are really solving the problem of the operating system for running containers. So we are really doing what CoreOS was trying to do at the beginning, becoming an operating system for that, but it's just the operating system side. If we put on top of that Kubernetes, we can really become abstract and not thinking that we are running Ubuntu, Windows, Mac, whatever. We're just running containers. Each container could be a part of the operating system that we like, of the application that we like, and we can fulfill the requirements of all the developers that are really thinking about running their application. So we don't care about how it's running. We do core concepts fun for all the people, including people that are not technical. They just like the way that Kubernetes is designed, the Kyber, no, the Kubernetes, the Helmsman, and so on. So what is also the usage of words? Think about the core concepts. What are pods in your normal language? When you think in English about pods, I'm Italian, so I don't have pods in Italian.
I don't know what it's called, but I've seen these seed pods before. Like I think they're mainly in lakes and stuff like that, or like a water flower. But when you look at it, it's a big container, or well, a structure like a seed pod that has lots of little round things that would be like a container. So when you think about it from that perspective, it is kind of a very organic kind of structure that they've created with groups of containers that ride together inside one pod. And it's another one of these constructs that is, I don't know how you would do distributed systems without it, right? If you didn't, it would be very difficult. Right? Like if everything was just a bunch of containers thrown into one giant pod, you would lose all sorts of control value that's built into Kubernetes, right?
Yeah, one of the big mistakes that people are doing at the beginning when entering the world of Kubernetes, they think that pods is synonymous of containers, but it's not. You are describing how we orchestrate group of pods. Then we have nodes. In Italian, nodo means knot. Like you're not with a rope, you do a knot. So for me, it was initially, what is this node about? But it's like the worker bee, the effective shipment for these kind of activities. The agent nodes with the kubelets, that is this way of interacting and running containers on top of the node. So that is also what does it mean really for an English native speaker hearing the word about nodes? What is that node?
I mean, when I think about nodes, to me, it's like a lot of other things in Kubernetes. It's a virtual abstraction of like hardware, for example. So you think about it as something, if you had pods, if you had all the containers in the pods, then you'd have to put it on some kind of a node for it to do anything. And this is like the translation part of Kubernetes to whatever hardware you're actually running on or what's being virtualized that you're using. But I mean, when I think about nodes, it feels to me like they carry the pods, right? So, you can use that kind of thinking to organize how you want to consider monitoring, how you want to think about like what's important, what needs to be on what node in the operation. And it also gives you some language to differentiate master nodes from worker nodes. And, the whole idea of how everything's organized within Kubernetes. So I think it's another piece that would be very hard. I don't know, I guess you could think of in pure VM terms, a different way to describe nodes, but I think it was a critical thought point for them to come out with that idea on, as pods on top of nodes on top of the control plane.
Well, when I think about nodes, I'm just thinking now that I learned English about a distributed system. So it's really exposing that concept. And I think about the other word that is very scary, control plane. So something that is like the master of puppets, to use a title of a song that we know. But in general, this way of controlling everything from a single point of view, in this case, the master of server nodes, to use other notation that because there is master server, agent worker, it depends on how they wake up, they invent a new name. But the concept is still that everything is controlled on the control plane where everything is orchestrated and controlled through these distributed nodes. And we do that with a language that is called YAML. And it's yet another misleading language. So we are misled completely when we do this kind of concept for Kubernetes. And it's not really misleading. It's just breaking the soul of orientation, because we have to be careful about how to manage the syntax and indentation of that language, but it's very good because it's descriptive. So with all of these things, I hope that people that are approaching Kubernetes for the first time, they will remember that there is pods, nodes, control plane, this YAML that is really the ability for us to write something that is understood by the whole ecosystem. And we just have to learn a markup language, not programming language. It's just describing what we want. So it matters.
When I think about this conversation, a movie that comes to mind for me in a book is Tron. Now, Tron came way, way, way before before Kubernetes. But
I was playing at Tron at the university, but don't say to the professor.
No, but I mean, they described a world where the control plane existed, and they had an MCP, master control program, that was acted like Kubernetes more than a master control program, like some kind of monolithic thing. But I think you could, when you watch that movie, you can think about all these pieces. I mean, they had a lot of pieces, like it wasn't as simplified as pods and nodes, but they had a lot of these kind of pieces. And when I think about the control plane, to me, in the past years, it was more of a limitation at some level of like Amazon's control plane or some kind of control plane you would create outside of Amazon, and the two things don't talk very well together. And some of that still exists, but when you think about distributed systems, you get into this concept of a control plane that is both, in the cloud only, as well as out in the field, living on hardware and stuff like that, where things that we've done, where you really need to have some flexibility in that part of the structure. and how things are orchestrated. And I think that's come since, in the last few years, it seems like it's exponentially improved as far as like how that all works and the limits of the control plane.
Absolutely. So when hearing about you now talking about the solutions on top of cloud providers, I'm thinking that they were forcefully putting the complexity on top of these words and concepts because of the need for locking you. So how we went to hybrid clouds, how we went to the ability of having this big advantage of Kubernetes enabling scale, self-healing, because it's able to do something that Docker Compose was not able to do. Just to recall that it's self-healing the containers. So I can have continuity in these kind of services. If something dies, it will become dies, to use the word typical that we use in IT, but it should be stopping the normal activity to restart. So do something. Kubernetes will do that for you. And for that reason, the complex system, the control plane that was managed previously to help, in double quotes, people and to lock them to use that provider, today is becoming easier to use because there are more people knowing the technology. So we have more hybrid cloud, more bare metal, more nested virtualization possible because we are using models that are getting out of that vendor locking option. They know about that. They are doing the same. But basically, it's not just microservices, GitOps anymore, closing the gap between the provider and the developers, but it's everything. So Kubernetes matters because it's becoming the standard for everything, and everyone is knowing much more as time goes by. So we are able to do things that previously were done only by big entities, the providers, and today are really available for us. So
yeah, I think it's one of the things that I think is kind of crazy about how far things have come with Kubernetes is I was talking to someone at a KubeCon recently in the last
what's
year.
that? KubeCon.
And and they were talking about Kubernetes running natively inside of a switch, a telecom switch. And I come from the telecom industry and spent many decades there, but those switches were so specially built, and everything inside of them was like one-off as far as how they were built. And there was a lot of differentiation between not just the switch hardware, but the switch software in the past, right? So there was a big difference when you went shopping for one of those devices, which only big companies did. But now with Kubernetes inside of a switch, it changes the communications in a very unique way. At some level, it increases the security challenge because those switches, 10 years ago or even 5 years ago, were so different from one another that it would thwart an attacker. Now with Kubernetes, if you could figure out how to get past it all, it creates a bigger need for higher security inside some of this equipment. But I think Kubernetes is, from what I heard, it's I haven't seen it, but I've heard it's shown up in control systems for military equipment, nuclear submarines, and so forth. I mean, that's amazing, right? That Kubernetes has shown up in these environments, which were usually totally custom built, right, from the ground up, right? And that was that value was bigger than the value of interconnectivity and control planes and stuff like that, right? It was bigger to have something that was one-off and a bigger value proposition to the military companies than it was to have something that can communicate better, faster, more flexibly. I think it's really a testament to the community that Kubernetes overall has gotten to be that good, that trustworthy. So
that's one question that I generally get always when going social or going to the events. You mentioned KubeCon, but the KCDs too. How much Kubernetes will be standing on top of the market? And the answer by the specialists, the people that are working there, it's always the same. A lot of years, decades, because we are working on top of it. So Kubernetes is something that will not die. And when someone is approaching for the first time, it's not just containers, Dockers. It's not just something that is simple and complex at the same time. It's not easy for sure because you have to learn a technology. But think about extending that learning ability to IT. It's a lot. But if you just have to learn Kubernetes, and I say just in double quotes because, I did that path becoming Cubestronaut. I wanted to be astronaut when I was a child. Then the shuttle exploded, so I decided to avoid being an astronaut. I became a Cubestronaut at the age of 53, and I really understood a lot of Kubernetes. It's not simple. It's not easy. You need people that are investing their time to understand how it works. Probably those advantages you were talking about, like role-based access control, authentication, authorization, policies to manage everything, network policies, a lot of security can be done by a special figure running on top of Kubernetes, their ability and managing that, and other people that are just like DevOps are able to run the translation of containers. But basically, also not being so easy. It's not just for big companies like the cloud providers we were mentioning. I remember that when I used a word that I generally use, cloud agnostic, a marketing person working with us said to me, I like that word, cloud agnostic, but it means a lot. So becoming agnostic to what is really the platform where you have to run that, or just becoming used to know the hardware, the base. That is something that Kubernetes is. It's not just for big guys, it's for startups. Is for whoever wants to include a technology that can be used. The management of that technology is not something that you will do daily, but really there is no need to be scared about what to select as a provider. It's more important to say, okay, I'm adopting Kubernetes because I will invest just on one thing, and my guys in the teams will just learn one technology, having everything inside
yeah,
of it.
yeah. I mean, I think as a product manager, that's one of the key factors, right? So like if you can decrease the uncertainty or the idea that you just don't know what platforms you're going to need to run this on in the future, right? You build something, it takes off, you don't know exactly where it's going to go, but you hope for the best. I think Kubernetes is a way to remain calm that, at the same time doesn't necessarily um, translate that calmness into like a fee that you have to pay to some company out there, right? So you can actually build something that's going to be a strategic platform and deal with a lot of these concerns that are going to come in the future by being involved with a community that is putting so much into a solution that it's likely to continue, and the other constituents who don't get any value from having us all on the same platform, those stakeholders, uh, the big companies, they still can get a lot of value out of us using Kubernetes consistently across their competitors and making things work. And we need to wrap up because we always go long, but I think these are some of the things that we plan on unpacking in episodes this year. We'll have a lot of focus on CNCF and who's in the community and what projects are out there and how they fit together, and some of our thoughts on, and battle scars from going through these processes of trying out some of these different projects, and also working with Kubernetes over the years. So we'll talk through some of all that detail, at least at where it's value. But I think that's it for today's episode of Clusterfunk. Again, I'm Ed Fullman, and he's
I am Fabrizio Sgura, but I was thinking that my wife was calling me because we are out of time. So the pod can crash, but you cannot crash your wife. So the pod can crash and Kubernetes will restart it, but your wife using Kubernetes will be very dangerous. So be careful about that. I have to go because she's calling me. I'm doing like the Lieutenant Columbo. My wife, I have to tell that to my wife.
Thank you for your attendance. Appreciate it. Thank you.